Hey guys, what's up? This is the Real Hacker Hours podcast. Basically, what this is me and a group of friends, we decided that we'll get together and effectively just do the things that we normally do, the various like InfoSec and VR projects. It's just we're going to hit the record button before we do it sometimes. One thing about, and we'll probably meme a lot too. One thing about this isn't rehearsed at all. This is literally just me doing work, so you're probably going to see a lot of smooth brain mistakes. But yeah, without further ado, let's get started. So right here, actually let me go here. See, right now, I'm trying to post SQL 3, and these are a bunch of errors that I outputted. One in particular that caught my attention was this parser stack overflow, which you can see in several places. So right now what I'm going to try to do is try to reverse this out and understand if this is something that we can actually use maybe. In Ghidra, using string xrefs, I was able to identify the function, which is YY stack overflow, that actually outputs that. So what I'm going to do is in GDB set a breakpoint for YY stack overflow, and I'm just going to give it the input, which is the content of the SQL queries file. That just holds all the SQL queries which we can use to fuzz it, and then we're going to wait to hit that function, the YY stack overflow, and see exactly where on the code that happens and try to reverse it out from there. So we run that, and we hit it. And one thing that I can just note off right off the bat is looking at the SQL query. It is super large with a ton of different parts. There's like a or not nested select statement within it, so there's just a mess, a bunch of stuff in it. And looking at it, run parser prepare. Yeah, looking at it, we can see the YY stack overflow function is called within the SQL 3 parser function. Right now, I kind of want to see how that happens, so I'm just going to use the finish command to effectively run through the entirety of this function. And now, since I compiled this with, since this is SQL 3 is open source, I was able to actually compile it with debugging symbols, and that's the binary I'm currently using. We can see here that it happens in this SQL 3.c with this code right here, which we can just copy this, go over to SQLite, go here. So this is effectively where the YY stack overflow function call is being made from. We see here there's a condition, there's an if condition to actually execute this, checking if two values from YYP parser is, and depending on that, look in the stack overflow. Looking here, seeing stack in, so there's probably some specific value indicating where the end of the stack is. Now let's see what type of data structure this is. We see that it is a, oh wait, no, I copied SQL 3 parser. This is just a copy of that function over into a separate tab. I did that so I could just do searches for specific strings much easier. We see here that there's the YYP parser it's the YYP parser variable is just a struct pointer to YYP parser, and doing some string greps, I was able to find it's in SQL 3 with this is the, yeah, it's right there, YYP parser. And looking here, we can see a few things. First off, top element of the stack, first stack entry, the parser stack, the parsers. Okay, looking at here, first thing that comes to mind is there a lot of YY stack entry. Looking at this, what it's looking like to me, yeah, this is just one of like those typical stacks that you see in like a CS1 data class. YY stack entry is probably a struct for an individual entry on the stack. So we see that. We also see int shifts left. Mark, where is current size of the stack? Stack depth. One thing, looking at here, we see if it's checking for YY stack end is that. Okay, so this is a integer integer comparison being done between the YY stack pointer and YYTOS, which is the top element. So what this looks like is, so this is a pointer. This is also another pointer. When it's doing a comparison, if this is the top of the stack, and there is an address, it's just checking if the address is past the end address of the top of the stack, in which case there is I would imagine there is an overflow, but let's keep looking. Let's see exactly where the stack entry actually gets allocated from. Okay, wait, sorry, SQL 3 parser. I zoned out for a second. Let's go Control F for this. Right here, if stack and YY parser. Let's take a wow. Okay, so this is a this is a loop that's going to run infinitely until some break condition is met. Let's just start looking through the code for here. Assert YY find shift action. Okay, that. Okay, looking at this, I know from previous reversing efforts that effectively. Okay, I'm going to take a step back and kind of explain exactly like where this what this functionality is in this whole entire SQL, like the greater scheme of things. So, SQL Server, what does it do? It effectively stores data. How does it do it? SQL is a programming language that you can send it code. It'll do various operations. It will either create data, edit data, or delete data, or maybe, and there's a few other admin things like creating users, but I'm not going to get into that. So how does it do that? First thing that it does is you will give it a SQL string and it will parse that out and effectively lex and tokenize it so it can actually like turn it into data that can actually like, oh hey, this is that it can actually like understand and perform the operations that it needs to. So this right here, this functionality I'm looking at right here is particularly just with the parsing functionality. It's not dealing at all with the actual like editing the actual tables or like viewing from that. So I'll explain that. One thing that I know from just past reversing efforts on this is the YY major and the YY act. I'm pretty sure that those actually those are two values that deal with just parsing it. It is the actual YY parser. So why am I ranting about this? I don't think the YY find shift function, while my later influence that directly does not influence the YY parser variable we're looking for. So if printf YY reduce. Okay, actually let's see where I'm thinking too hard. let's just see exactly where this variable is called from or referenced. Okay. Declared basic check yy actual equals, okay, grabs a constant, some more asserts, size f printf produce. Looks like it appears to be some sort of like debugging error output. Parser, check this down. So that's a check. I'll just read this comment right here. It's I reduce IP. Okay, so this function probably does influence it somehow. There's the reduce shift TOS. That might be something because it's shrink. This right here is shrinking the YY TOS, which actually that has to be greater than stack in from this condition to be checked. Let's continue looking. Syntax error, create action, YY shift. Okay, so let's just take a quick look at, let's see, like what, like, yeah, right now I'm just looking for like what function calls actually take YYP parser shift. Okay, so we see YY shift takes it. I'm just gonna jot them down here. YY destructor, YY parse failed, YY pop parser stack takes it, reduce action, already got destructor. YY syntax error, I might look into that later. That might deal with some other issues, although probably won't yield anything on that beneficial. YY accept, take a look at that, and shift reduce grow stack. That seems interesting. Okay, save that. Okay, looking at that, like, I might have missed a function, but, like, for the most part, these are the functions that appear to actually deal with the YPP, or, yeah, the YP parser struct. Just taking a look at the names, grow stack might be interesting, accept might be interesting, syntax error probably is going to be interesting for what we're going to look at. Find, reduce, action, same thing. Pop, we're kind of might actually, we're looking, it's a stack overflow, and popping reduces the size of the stack, so it probably is not going to be what we're looking for. Destructor, parse fails. It's probably these three, the YY shift, accept, or grow stack, that might have the functionality that we're looking for. By the way, effectively what I'm trying to see is the functionality for how the stack grows, and I'm thinking it might be in these three functions, so I'm gonna guess it's YY shift first. Let's take a look. shift. I'm guessing it's an int. Nope. Void. Yeah, perform a shift operation. It's this right here. Let's take a look. What do we have here? The parser to be shifted. The new state. The major token. The minor shift. Interesting. I see the same. Yeah, the same check that we failed is done here. Looking at this, it appears like this function has like this the code. It looks pretty similar here to it did in the SQLite 3 function. Yeah, it's looking pretty similar. Cancel, don't want to close that out. So, I'm not thinking it's this function, looking at that. Let's take a look at YY grow stack. YY grow stack. So I probably could have looked earlier, but it's probably, yeah, an int. Okay. Try to increase the size of the parser stack. Let's take a look here. So, new size IDX, the new entry. Okay. So, actually, the only thing it takes is that the YY parser's argument. Let's see, pnew. Does it get malloc size of pnew equals new size times. Is pnew initialized to anything? New size. What's new size? Okay, so looking at this, we see that there's the YY stack function is set equal to the return address of a malloc call. Now, looking at it, we see, what do we see? We see that the size is controlled by two different things, new size and the first entry of pnew. New size is equal to this, which I'm assuming what this, why, actually we can just look at what this is. Current size of the stack times 2. So the new size equals the current size of the stack times 2 plus 100. Then malloc that time size of pnew 0. Probably need to look at the structure to get a better idea of what that is exactly. If YY stack is equal to, actually wait, there's a if then condition there. If YY stack is equal to YY stack 0. Let's see what these two values are. So YY stack is the parser's stack, not quite sure what that is. And YY stack 0, let's see what that is. First stack entry, so if the parser stack is equal to the first entry of the stack, not really too sure what the difference is. If they're the same stack or if they're two different, they're probably the same stack, just a guess. Then it's malloc else this happens, which I'm assuming that this probably happens a lot more than the above function. Above, all of this conditional is probably only executed the first time it's ran. So realloc, let's take a quick look. Realloc Yeah, like takes void 2R. Yeah, 2. I'm just looking at the man page real quick, just to get a refresher on exactly what React's functionality is. Yeah, like function changes the size of the memory by pointer to by pointer. So okay, so effectively it just takes this mem block and just like reallocates it to be this new size. So either way, pnew is going to be set to effectively a new heap size chunk of that size. Cool. So yeah, I just wanted to make sure that like I wasn't about to have my bad memory screw up what I thought React does. Okay. So if pnew is not equal to 0, so if malloc was able to actually successfully return a valid heap pointer, we see that the stack is set equal to that, and YYTOS, which I think it's the size, if I recall correctly. Let's see. I thought I had the struct for that open. Yeah, here is YYTOS pointer to the top element of the stack. Okay, so yeah, effectively we can see like here, like this is the functionality that where it's actually where yeah, we'll actually grow the stack and add on an additional piece to it. Now, while it will do that, it doesn't appear to actually write to the entry. That's probably done in a subsequent function call. So let's try to see where that happens. Looking at SQL 3 parser. Maybe it's done it. No, can't be done. One thing I just caught my eye right now is looking at these at like the SQL queries. You can see here it begins with an update, and this is also a SQL query. However, it appears to be a subset of the previous one. Reason why I can tell that, first off, it's smaller. Second off, this begins with an update, and that doesn't. So I'm just gonna take a quick look at this real quick. I'm just gonna copy this and then grab that. Do Control F. Yeah, we can see here it's here, and interestingly enough, we can see it's select all from. So it's a few nested select statements. Okay, there's something good to keep in mind. Okay, let me. Hang on a second. I'm gonna pause the stream real quick. So I have to go right now, so I'm gonna cut it off here for now. See you guys later. Bye.